Let me give you a code-free example of how AI works and how you can play around with yourself. First of all, it is important to understand that AI can be a lot of things. However, at recent time one would probably refer to more advanced AI such as neural networks. It is also important to have in mind that neural networks can be a lot of things, and the network provided here is just a simply trained network that will give you an idea how it all works. Below you will see a picture from Excel trying to predict the handwritten digit in a 28x28 grid. All cells are turned into a range between 0 and 1 indicating the grayscale of the digit. You see that it is 96% confident that this number is an 8. So how you could let Excel guess what this number is? There could be several methods. Maybe you use the equals sum function to take the sum of all the cells, and tell it that the probability it is an 8 is higher the more pixels are colored, as 8 is typically covering a lot of pixels. Maybe you would use a combination of equals if functions, to tell it that if certain areas contain values, we will guess X number. Maybe you play around with it enough and get an accuracy that is fairly high. Random guessing is 10%. However, consistently getting above 90% accuracy requires advanced methods, and one of them could be a neural network. If you are already familiar with neural networks, you might have seen this illustration before. NB. The following example uses n equals 30 in the hidden layer 1. What we see is that it is simply some parameters that are initialized and in the end provides an output based on the input given. This is exactly what our Excel file does. The Excel file contains 3 sheets: model, parameters, numbers. Let's have a look at parameters. What we see are matrices of weights ranging from weight_1_1 to weight_1_30 with dimensions 28x28. So what are all these numbers used for? It is used for our formulas in the cells sigmoid 1. So if we refer back to our previous illustration of the neural network, we see that each input has a weight going over to a new neuron in the hidden layer. So this is basically what's going on here. The first hidden neuron located in cell AD2 simply has the 28x28 input pixels multiplied by each weight in the first matrix of weight_1_1, and then a bias. Biases are located further down in the parameters sheet is added. All of this is then squeezed into the sigmoid function. So let's quickly review the formula in cell AD2. Where X is the matrix of the input pixels and W is the matrix of the weight_1_1. I. E. The upper left pixel is multiplied by the upper left weight. This is done for all 784 weights and pixels, and the sum of this plus a bias in the end we call Z. This is then put into the sigmoid function and we get our output in cell AD2. The same is true for our sigmoid 2 range. If you think back to the illustration of the network, you will remember that there are fewer weights connecting the second layer to the output layer. As you see, we do it all over again for our output layer, just with fewer weights, and this time treating all the results we got from sigmoid 1 as our new. As you have noticed, the second list value has the highest activation, indicating that this number should be the number 8. Let's just have a look at the last sheet called numbers. Just to show that the correct values of the numbers are not already given to the network. As you see, this is just a sheet containing a lot of handwritten digits converted into 28x28 ranges with numbers ranging from 0 to 1. Now you might wonder, but how did we get all these weights and biases in the first place? That's a very good point. And to answer this question, we would have to know a bit about how to optimize parameters. For this, we use an algorithm called gradient descent. But for now, I think we should stop here, and just focus on that you actually understand the structure of a neural network now. I hope this little example has shown you how much neural networks are actually dependent on math and parameters, and is not any kind of voodoo magic, as one of my readers commented in another of my posts. Update: I managed to remove the VBA code to generate numbers, so I could upload for you guys to play around with. In order to see a new number, just double-click the number to the right, or manually enter something between 0 and 999. Here is a link, MNIST_neural_network Quora XLSX. Footnotes. 1. Neural networks and deep learning.